Hello students, welcome to this particular video where we are solving section D and E of our paper 1. Paper 1 we had selected was the Arun High School Dubai term 1 sample paper. We have already solved section A, B, C in separate videos. Please have a look at the links provided in the description if you want to solve these. Remember, this is part of a paper solving series which I'm doing for 9th grade. It's based off the new portions based on the chapters from Ganita Manjari. 3 chapters in this paper, real number systems, you have coordinate geometry and probability. In today's video, since we are solving section D and E, we're going to come across case studies and the important concept of proof of irrationality. Prove that root 2 is irrational. Prove that root 3 is irrational. I know these type of questions are confusing for some of you. So these type of questions are going to be covered in this video. 2 ways of approaching the video. You can download the question paper provided in the description and attempt the paper before actually going through the explanation. If you want to do it along with me, no problem. Just make sure that you pause the video so that you can have a look at the question, read it, try to attempt it first on your own before you actually listen to my explanation. Let's get started. So section D, first question. This is based off coordinate geometry, 24th question. Show that points 1, 7, 4, 2, -1, -1 form an isosceles triangle. What is the meaning of an isosceles triangle? An isosceles triangle is a triangle which has 2 equal sides. Since length of sides is involved in this question, we are going to be using the distance formula, which is useful to find the distance between any 2 points, x1, y1 and x2, y2. It can also be used to find the length of a line segment whose coordinates of the endpoints are known. So when you know the coordinates of the endpoints, how do you get the distance formula? It is root of x2 minus x1 the whole square plus y2 minus y1 the whole square. Difference between x coordinate square, difference between y coordinate square. Remember, this is nothing but an extension of the Pythagoras theorem. Why? How is this Pythagoras theorem? See, if you have any 2 points in your coordinate plane, x1, y1 and x2, y2. Imagine that I join these 2 points here and this is the distance that I need to find. What if you complete a right angled triangle over here, which gives you the vertical distance between the 2 points and the horizontal distance between the 2 points? What will be the measurement of this horizontal distance over here? That will be the difference between the x coordinates. This horizontal distance is nothing but the difference between x coordinates. And what about this vertical distance here? The vertical distance is the difference between the y coordinates. So you get y2 minus y1. Since this is a right angle triangle, when you apply Pythagoras theorem to the sides x2 minus x1 and y2 minus y1, you get the distance between the 2 points. That's how this formula comes about. It's nothing but the Pythagoras theorem. Hypotenuse is square root of sum of squares of other 2 sides. What are the other 2 sides? It's x2 minus x1 and y2 minus y1. Let's apply these concepts to this question and also see how you're supposed to present your answer. First, what you're going to say, let the points be A, 1, 7. So I'm labeling the points basically. B, 4, 2 and C, -1, -1. It's a good habit when you get a 5-mark question like this that you quickly cross-check whether the values you copied from the question are correct or not. So that's what I'm checking here. 1, 7, 4 comma 2 minus 1 minus 1. Okay, I got that right. Now what we'll do, we'll find the distances between these points. I'm finding AB. I get AB measurement as root of difference between the x coordinates. Now I could do x2 minus x1 or x1 minus x2. It didn't matter for the distance formula because ultimately I'm going to square the value. 4 minus 1 would be 3. I get root of 3 square. Then what about the difference between the y coordinates? See, we could do 2 minus 7 or we can do 7 minus 2. If I do 7 minus 2, I get plus 5 square. So we have root of 3 square plus 5 square. What is this value? You will have here root of 9 plus 25, which is equal to root 34 units. This is the measurement of this side AB. Let's check the measurement of another side. So if you look at BC, what is BC equal to? BC would be square root of difference between x coordinates. So I could do minus 1 minus 4, which is minus 5. Or we can do 4 minus minus 1 plus 5. Both ways it's okay. Important thing is you're taking the difference between the x coordinates. And that difference happens to be positive 5. So I get 5 square. And then again over here, 2 minus minus 1 the whole square. Or minus 1 minus 2 the whole square. So 2 minus minus 1 becomes 3. I get plus 3 square, which again should be root of 25 first plus 9. Same, root 34 units. Now, since this is a 5-marker question, I would advise you to put the distance formula as part of your steps. That way, if there's any calculation mistake, you still get step marks for writing the formula correctly. Also, since it's a 5-marker and you want to be awarded step marks when you're finding any distance, see here I've already got AB is equal to BC. It's already proven that it's isosceles because both these sides happen to be equal. But when you're finding the distance, let's say I'm finding out AC over here. AC will be root of 1 minus minus 1 the whole square plus 7 minus minus 1 the whole square. So it's a good idea to write your step like this. Yeah, you actually write down how you're substituting the values into the formula. This way you get some step marks even if your calculation goes wrong later. I'm getting here AC is equal to root of 2 square plus 8 square, which is root of 4 plus 64, which is root 68 units. So what has happened over here? We wanted to just show that these points form an isosceles triangle. We got AB equals BC, which is equal to root 34 units. And it's not equal to the third side. If it was equal to the third side, it would have been an equilateral triangle. It is not equal, that's okay. You can just say since these two sides are equal, that triangle ABC is isosceles. One extra point which I want to mention to you. Do you notice how in this question, if I found AB square plus BC square, AB square plus BC square would become root 34 square plus root 34 square, which is 34 plus 34, 68. What does that mean? Here, AC square is equal to root of 68 square, which is also equal to 68. So this means that the sides are satisfying Pythagoras theorem. You get AB square plus BC square is equal to AC square, which is nothing but the Pythagoras theorem. So actually, not only triangle ABC is isosceles, triangle ABC is an isosceles right-angled triangle. So that is extra information, all right? For this particular question, you only have to write so much. And by the way, this could have also come for 3 marks in your paper. For 5 marks, normally what I would expect is show that the points form a right-angled isosceles triangle. So if they ask you, show it forms a right-angled isosceles triangle, you need to show that two sides are equal. You also need to show that when you square the smallest two sides and add them, it becomes equal to the square of the largest side. And that means it satisfies the Pythagoras theorem, hence it is right angle. That's the concept behind this 24th question. Okay, 25th one. 25th one deals with proof of irrationality. So they're asking prove that root 2 is irrational, prove root 3 is irrational. It's an or question, which means you just have to attempt any one. It didn't really make a difference because the steps for both are very, very similar. It's just a change of number from 2 to 3, right? But the steps are exactly the same. Now, I know that many of you get confused by this proof. Let's try understanding what this proof is all about. See, the way you prove irrationality is by using a concept called proof by contradiction. What is an irrational number? How does the decimal expansion of an irrational number look like? An irrational number is a number which is non-terminating and non-repeating. So it won't terminate and there is no repetition, right? So non-repeating. Something with a non-terminating, non-repeating decimal expansion is called an irrational number. Okay, let's say I have three students, A, B, C. Okay, I'm shortening their names as A, B, and C. I ask student A for an example of an irrational number. Student A tells me, ma'am, 1.235 dot 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 is an example of an irrational number. Student A will say that it does not terminate because I put these dots. So it's non-terminating. There's no pattern over here, so it's non-repeating also. That would be student A's logic. Then student B will challenge, what if the number is 1.235 dot dot dot. Then student B will be right. Student B is correct, right? Student B is saying that the number is 1.235. That means this number was not irrational because the 235 part got repeated. Now student C might challenge B. What will student C say? Oh, you're wrong. It is actually irrational because the number is 1.235, and then 115 and then dot dot dot. So are you understanding the point over here? You can have a repeating set of digits appearing after many, many digits, or the repeating set of digits never come across. So both ways are possible, but unless you are finding out many, many, many more digits, you cannot just use the decimal expansion alone to convincingly prove to someone that the number is irrational. Someone might find out the decimal expansion to 100 digits. Someone else will challenge that by finding it to 200 digits. So how do you convincingly prove that a number is irrational? The logic we use is this proof called proof by contradiction. What is the meaning of contradiction? Contradiction means showing that something is wrong by providing an example which challenges the original assumption. To understand what proof by contradiction is, let's take an example. Let's say I have a student, Chris, okay? And my goal is prove that Chris is intelligent. Prove that Chris is intelligent. That's the goal. I need to somehow prove Chris is intelligent. Now, let's say that I choose proof by contradiction to prove that Chris is intelligent. So what is the basic structure of proof by contradiction? Basic structure is, first we start by assuming the opposite. So we will assume that Chris is not intelligent. I assume Chris is not intelligent. Okay? We start by assuming Chris is not intelligent. Now, what I'll do then is, I will try to intentionally see whether there is anything which challenges this particular point. See, if my assumption is true, then nothing in the world should be able to challenge that. No one should be able to give me any facts, any tests, any evidence that my assumption is false. If my assumption was false, then Chris is intelligent. If my assumption is true, that means Chris is not intelligent. How will my assumption become true? How will my assumption that Chris is not intelligent be true if nobody is able to give evidence which is countering it? Now, what we can do to counter this? We can maybe do an IQ test. So, I'll conduct an IQ test of Chris. When I conduct the IQ test of Chris, I find Chris has an IQ of greater than 120. Now, if you're having an IQ level greater than 120, that means you're certified, you're an intelligent boy, right? So, an IQ level of more than 120 tells that this is evidence that it is not possible that your assumption is right. It's not possible that Chris is not intelligent. So, I have challenged your assumption. I am telling your assumption is wrong. If the assumption is wrong, what is the logical conclusion? If Chris is not intelligent is false, then the logical conclusion would be that Chris has to be intelligent, right? It seems like a little roundabout way of proving something, but since we saw the challenge in getting the decimal expansion of an irrational number, this seems to be a better way of proving a number is irrational, a proof by contradiction. So tell me, what would be the assumption in this case? If I have to prove that root 2 is an irrational number, how do we start? I will start by assuming the opposite. Assume that root 2 is rational. Start with this assumption. Assume that root 2 is rational. Now what we will do is, we'll do a series of steps with this assumption. Keeping in mind root 2 is rational, we'll go into some logical steps, but we'll show that there will be some problems which come along the way. See, if root 2 is a rational number, it should satisfy all properties of rational numbers. We should be able to do all sort of rational number calculations with this root 2. If there is an issue somewhere, something which does not make mathematical sense, something to contradict this particular statement, that means our assumption is wrong. And if our assumption is wrong, the only possibility is root 2 is irrational. You cannot have a number that is both rational or irrational. Either it is rational or it is irrational. So if it is not rational, I give sufficient evidence for that, then 100% it is irrational. So we are going to try and purposely create problems here. How do we do that? When we assume that root 2 is rational, any rational number we know can be written in P by Q form, where P and Q are integers. So I can say that root 2 is equal to P by Q. Now you cannot divide by 0 in mathematics. That's not valid. So I will write Q is not equal to 0. Another important thing is that P and Q both must be integers, right? Now imagine that your rational number was a number like 4 by 6. This is P, this is Q. We know that we can cancel common factors, right, from rational numbers if there is something common over here. So these numbers are not co-prime. What do you mean by co-prime numbers? Co-prime numbers have highest common factor as 1. These numbers are not co-prime because 2 is there as a common factor. Let's say that I'm cancelling 2. So when I cancel 2 from the numerator and denominator, meaning I'm dividing both numerator and denominator by 2, we get 2 by 3 over here. What type of numbers are 2 and 3? Both are prime in fact in this case, which means by default they are co-prime. These are co-prime integers. Remember, co-prime integers has highest common factor as 1. So 4 and 9 are also co-prime because there's no common factor between 4 and 9. 4 and 9, highest common factor is only 1, no other common factor. So we can reduce any rational number to its simplest form by cancelling common factors, right? Which means I could have said let root 2 is equal to a by b. For example, after cancelling the common factor p and q, let's call what I got as a and b. So I can say let root 2 equals a and b, where b is not equal to 0. A and b are co-prime integers. instead of this being our first step, we could write this as the first step. Okay? After which, you can say that, okay, this means that A is equal to root 2B. That is simple. If root 2 is equal to A by B, A is equal to root 2B. Next step, which you need to remember, is that we are going to square both sides. Why are we squaring both sides? Because we want to remove this root symbol and work with the number 2 here. So square both sides. Squaring both sides results in A square equals root 2b the whole square. Remember, root 2b the whole square will be 2 times b square. Root 2 square is 2, b the whole square is b square. We get A square is equal to 2b square. What does this mean if A square equals 2b square? It means that the product of 2 and a number b square is equal to A square. See, when I have 2 into, let's say, 3 is equal to 6, what does this mean? It means that 2 can divide 6 perfectly. Or you can say 3 can divide 6 perfectly. Right? 6 can be divided by 2 perfectly, 6 can be divided by 3 perfectly. So, when I say 2 into 3 is equal to 6, I could also say 2 is a factor of 6. Or I could say that 3 is a factor of 6. Here, if A square can be written as 2b square, this means 2 is a factor of A square. Okay? 2 is a factor of A square. Let's take some examples of numbers where 2 could be a factor. And we are talking about perfect square numbers. Some examples of perfect squares which are divisible by 2 is what? 4. We know that 4 is divisible by 2. We have 16, which is a perfect square, which is divisible by 2. 64 is divisible by 2. So 2 is a factor of A square, means you could have numbers like this, 4, 16, 64 and so on, all of which would be divisible by 2. Now, I want you to notice one thing about these numbers. 2 is a factor of 4, 16 and 64. What is the square root of these numbers? It is 2 and then you have 4, 8. So when A square is 4, 16 or 64, we can see that A would be 2, 4 or 8. What is common between all these numbers? 2 is a factor of A also over here. If 2 is a factor of A square, then 100% 2 would be a factor of A also. So I could say if 2 is a factor of A square, 2 is a factor of A. Let's go through what we did again. First, I took root 2 as A by B, where A and B both are co-prime. A is equal to root 2 multiplied by B. You square both sides. When you square both sides, you get A square equals root 2B the whole square. After squaring both sides, we figured out that 2 is a factor of A square. And from these examples, we saw that if 2 is a factor of A square, 100% even A would be there in 2's table. So 2 would be a factor of A also. Now, if 2 is a factor of A, then I could write A as what? 2 times a new number, no? Like this A over here, 2 is 2 times 1. This is 2 times 2. This is 2 times 4. So I could say that if A square is 2 times B square, this A over here could also be written as 2 multiplied by some new number. So A can be written as 2C. Now let me call this equation as 1. And let me call this equation as 2. I will substitute 2 in 1. What do we get when we substitute 2 in 1? When I substitute 2 in 1, we get 2c the whole square. So remember, I'm replacing a with 2c. Keep that in brackets and square the whole thing. Remember, whenever you replace any variable with an expression which is like the product of two terms, you make sure that you put it in brackets so that you square it correctly. So a square will be written as 2c the whole square. This is equal to 2b square. What is 2c the whole square? 4c square. 4c square equals 2b square. If 4c square equals 2b square, I could divide both sides by 2 and we get 2c square equals b square. This tells you that b square is the product of 2 and c square. Okay, now this looks a little similar to our previous expression. I saw over here that 2 is a factor of a square when we got a square equals to b square. So if 2c square equals b square, that means that 2 is a factor of b square, right? We have 2 as a factor of b square. If 2 is a factor of b square, from our earlier discussion, what logically follows? Logically, if 2 is a factor of any square number, we know that it should be a factor of the square root also. If 2 is a factor of b square, 2 must be a factor of b. That is the logical continuity which we get over here. Okay? Are you all still with me? Do you remember what we are trying to do? We have assumed that root 2 is rational. Okay, we have assumed that root 2 is rational. If root 2 is rational, what did we write root 2 as? We wrote it as a by b. That was the beginning step. What type of numbers were a and b supposed to be? Co-prime integers. What's the meaning of co-prime integers? No common factor except 1. Okay. Why are we doing all this? We are trying to prove that actually root 2 is irrational, right? That means we want to create a problem over here. We want to show that there is something wrong with these steps, which shows that our initial assumption is wrong. Something is there which contradicts everything which we said initially. That has already happened over here. Did you realize what the contradiction is? See, we told that A and B are co-prime. So they're not supposed to have any common factor except 1. But what has happened over here? See, from this statement, which I will call equation 3 because I already have 1 and 2. So if I call this 3, and from this statement, which I'll call 4, I can say that from 3 and 4, 2 is a factor of both A and B. But there's a contradiction here. But this contradicts. Contradicts means this goes against the basic principle of what? This contradicts the fact that A and B are co-prime. So there's a contradiction here, right? A and B were supposed to be co-prime, which means no other common factor. But we've got here 2 is a common factor of both an A and B. Why has this contradiction occurred? Why did this mathematical problem occur over here? Because we began with the wrong statement itself. And what is our first statement? Assume that root 2 is rational. So we say over here, this contradiction is due to our incorrect initial assumption. This contradiction is due to our incorrect initial assumption. Therefore, root 2 is irrational. Okay, that's the idea behind proof by contradiction and how you write down that root 2 is irrational. Please go through the video again, pause, try understanding each step and learn this answer properly because this is a very common question which comes in exam. It's almost guaranteed that one of these questions would appear for you in the exam. What I will do now is, I will write down all the steps together for the second part. Prove that root 3 is an irrational number. So this will be like a revision for us also for this previous part that we did. Okay. So suppose I was attempting the OR part where root 3 is an irrational number. What's the first step? We write, assume that root 3 is rational. Okay, this was like, assume that Chris is not intelligent, right? Now what we need to do after this, we need to conduct some IQ test, right? Which shows that actually Chris is intelligent only. So we are trying to create a problem with our assumption. That problem involves writing root 3 as A by B where b is not equal to 0, a and b are co-prime integers. Okay, then what do? We can say a is equal to root 3b, square both sides. When you square both sides, you get a square is equal to 3b square. Remember, when you square, you need to square root 3 and b both. So you get a square equals 3b square. This means that 3 is a factor of a square. Sometimes in school, you might be learning this statement as 3 divides a square, and that's correct. 3 is a factor of a square, which means that 3 is a factor of a. The reasoning I have already explained earlier, why this happens. If 3 is a factor of a perfect square number, for example, 3 is a factor of 81, which is a perfect square number, then 100% 3 would be a factor of the square root of 81, which is 9. Okay? We can call this one over here as statement 1. Okay? And I would say let A equals 3c. Since I can say that 3 is a factor of a, I could say let a equals 3c. We will substitute this over here in a square equals 3b square. So we can say that 3c the whole square equals 3b square. 9c square equals 3b square. How do we simplify this? We get 3c square equals b square. If 3c square is equal to b square, that means 3 is a factor of b square, which automatically means that 3 has to be a factor of the square root. 3 is a factor of b. Okay. Earlier I had labeled 4 statements, 1, 2, 3, 4. Here I am just labeling this. 3 is a factor of a and 3 is a factor of b. Now, from 1 and 2, what do we get? From 1 and 2, we obtained now that 3 is a factor of a and b. What does this contradict? The fact that a and b are co-prime. You can just mention over here, but a and b are co-prime integers. Right? But a and b are co-prime integers. So 3 is a factor of a and b, but a and b are supposed to be co-prime integers. What does this mean? This means a contradiction has occurred. Why has this contradiction occurred? This contradiction is due to our incorrect initial assumption. That means we are getting a contradiction that the IQ test, he got a high score. Why is that contradiction happening? Because our initial assumption that Chris was not intelligent was actually incorrect. And if that is incorrect, it just means that actually Chris is intelligent. Okay? So this contradiction is due to our incorrect initial assumption. So what's the conclusion? Hence, root 3 is irrational. You can follow the same set of steps for any question which talks about irrationality, whether it is root 2, root 3 or root of any other prime number. It can be root 5, root 7. It's just that this number would change. Every other step remains exactly the same. Okay? All right. So that took some time and I did spend some extra time on this because I know it's a confusing concept. All right. 26th question. The 26th question says, with the rectangular axis, plot the points 0, 0, 4, 0, 0, 6. Find the coordinates of the fourth point B such that OABC forms a rectangle. See, since they're asking you with rectangular axis plot the points, you're expected to draw the XY axis properly in case graph paper is not given. If graph paper is given, then use a graph paper and draw your lines. So you will have to draw a y-axis, which is a vertical line. You will have to draw the x-axis also. Now, I could mark over here some points. 1, 2, 3, 4, 5, 6. Here -1, -2, -3, and so on. Here I have a coordinate 0, 6 coming into picture, which means that I need a little more space on my y-axis. So let me do that. That's the y-axis. I have 1, 2, 3, 4, 5, 6. Remember, I'm taking the same units on the x and y axis. 1 unit is equal to, 1 centimeter is equal to 1 unit. The same thing I'm taking on the x and y axis. Where do we mark the point 0, 0? Mark all this using pencil, okay? So 0, 0 is the origin, which is this point. Label it, that's 0, 0. Then you have 4, 0, which is on the x axis. So the y coordinate is 0, which means this point is on the x axis. You have 0, 6. 0, 6 would be a point on the y axis. So this would be the point 0, 6. You can mark that. Find the coordinates of the fourth point B such that OABC forms a rectangle. Since they've asked you to plot this on the graph, this is actually quite easy. If I am going to try and plot these points, okay, and if I'm allowed to use my coordinate axis itself to find the point, I know that the fourth point must be what? The fourth point must be 4, 6. That's the logic over here. Okay. However, what if you did not have an option to plot these points on a graph like this? In that case, what do? We will use property of any parallelogram that says that the diagonals bisect each other. Yeah. Remember, diagonals bisect each other in any parallelogram. What does this mean when I say diagonals bisect? It means that no matter what type of parallelogram you have, whether it is a rectangle, whether it is a square, a rhombus, or just a general parallelogram, the diagonal's midpoint would always be the same. So if I'm having a parallelogram ABCD, or as in this question, a rectangle ABCD, the midpoint of both the diagonals must be exactly one and the same. So midpoint of AC must be equal to midpoint of BD. When you get such a question with a missing vertex, where it was not easy for you to draw the figure, when you don't have a graph sheet given to you, then what do? Let's consider over here OABC as given in this question. Okay, so in this question, the information which is given is I'm having origin, which is 0, 0. I have a point A, 4, 0. We have a point C, which is 0, 6. The rectangle is OABC. So OA and then B should come in C's over here. Okay. OABC. What are the coordinates of C? 0, 6. We have a missing coordinate of B over here, which should be, let's say, X, Y. Our goal is to find out this value of X and Y over here, which is the missing vertex. How do we do this? Using this property. Midpoint of AC must be equal to midpoint of OB. What will be the midpoint of OB? What's the midpoint formula first of all? It will be sum of x coordinates divided by 2, sum of y coordinates divided by 2. This is the formula for the midpoint. Add x coordinates, divide by 2. Add y coordinates, divide by 2. When you add the x coordinates of OB, okay, when you add the x coordinates of OB, we get x plus 0 and then you divide by 2. What about the y coordinates? Y plus 0 divided by 2. This would be the midpoint of diagonal OB. What about the midpoint of diagonal AC? If you look at AC, the midpoint would be 4 plus 0 divided by 2 because the x coordinates are 4 and 0. Add them up, divide by 2. What about the y coordinates of the midpoint? 6 plus 0 or 0 plus 6 divided by 2. So this midpoint of one diagonal is equal to midpoint of the other diagonal. Now, how do you exactly get this missing value of x and y, which was the vertex there? You can equate both the x coordinates to each other and you can equate both the y coordinates to each other. When we do this, we get x by 2 is equal to 4 by 2, which means that the numerator must be equal. X is equal to 4. We also know the y coordinates must be equal to each other. Any two ordered pairs equal to each other means equate the corresponding x coordinates, equate the corresponding y coordinates. Y plus 0 by 2 is equal to 0 plus 6 by 2. This means y by 2 is equal to 6 by 2. Denominators are equal, so we can directly equate the numerators. The missing vertex is 4, comma 6. The same answer which we got over here when we were drawing the grid. It was 4, comma 6 only. So you can use a proper grid to answer, that's fine. But to mathematically calculate the answer when the graph sheet is not present, make sure you're using the midpoint formula concept. Diagonals bisect each other, midpoint of one diagonal equal to midpoint of the other diagonal. Okay? So we are done with section D over here. Let's look at section E. If we look at section E, what do we get? This is the first case study based question. Usually what happens in these case studies is there'll be some story which is given. Most of the time, the story is not important for you to answer the question. In few cases, there'll be some numbers present in that initial story which you need to use for the answer. But here it's quite clear that this story is just talking about someone who's learning number system and there's no numbers mentioned here. So don't waste your time trying to read the passage and understand it. It's not really important for you to answer the questions that follow in this case. The first question over here is asking convert the rational number 2 by 15 into a decimal number. Convert 2 by 15 into a decimal number. For this, what do? We know that 2 by 15 over here, if you look at the denominator, it's 3 multiplied by 5. There is a factor other than 2 or 5 present over here. So this has to be a non-terminating but repeating decimal place, right? Let's find that out. So when you do 2 divided by 15, we will have 0.1 and then 15, remainder is 5. You get 15 into 3 is 45. The remainder is 5 again. So we know that when we put the 0 over here, again we are going to put 3. Again the remainder would come 5. This 3 will keep repeating. So the value of 2 by 15 is going to be equal to 0.1333 dot dot dot. You could also write this as 0.13 with the bar on 3 to show that 3 repeats. So that's the first question done. What about the second one? Write one irrational number between 2.365 and 3.125. All you need to make sure is that the number is non-repeating and non-terminating. So if I start with, you see this is 2.3 and this is 3.1. Maybe I can have a number starting with 2.5. Then you can make sure that you write some pattern where it is obvious it is not repeating, not terminating. So for example, if I show a pattern like 50 and then 500, then 5000, 50000 dot dot dot. 100% this is not repeating. Yes, it looks like there is a pattern to it, but if you see 50, 50, then it's not 50. There's no repetition. If I consider 505, no, the next one is not 505. There is no repetition. So basically, there is no block of digits which is getting repeated again and again. This could be one example. You could provide any example of your choice. You could even have said 3.012345 dot dot dot. This is non-terminating, non-repeating, right? Okay. What about the third one? Find the product of two irrational numbers, 3 plus 2 root 2 into 3 minus 2 root 2. You can use a plus b into a minus b equals a square minus b square identity over here. We will get 3 square minus 2 root 2 the whole square. What is 3 square minus 2 root 2 the whole square? You will get this as 9 minus 2 root 2 whole square would be 4 into 2. Yeah. This is 9 minus 8, which is equal to 1. It's a good idea to remember that the square of 2 root 2 is 8. So you can then directly answer it as 9 minus 8, which is equal to 1. There was an OR question also for this. That's also similar. Try answering it yourself. Pause and try. So what do we get? 7 square minus 3 root 2 the whole square if you were doing the OR question. Because you can see here also you have a plus b into a minus b. So it's a square minus b square. We get this as 49 minus 3 square is 9. Root 2 square is 2. You will have 49 minus 18, which is equal to 31. Alright? Okay. Let's look at the very last question of the paper and the second case study over here. This is based on coordinate geometry. So again, there's a lot of information given here. I have a graph, and then if I see there is an explanation of what's going on in the graph which is given here. In the above picture, one small square is 1 kilometer into 1 kilometer. So we know that every single centimeter on the graph represents 1 unit dimension. We are starting from the point 0, 0. Deepak started to drive towards home. Let's see that everything is already marked in the figure. You're starting from 0, 0. You are driving towards home. First drove 3 kilometers to the left. Okay, so that's what's given here. 3 kilometers to the left. Then 2 kilometers. Then drove 2 kilometers where he found a temple. Okay, so everything is marked over here actually. Then he moves right, I guess, towards the zoo. That would be the information given. See, worship there drove 6 kilometers in his left. It looks like our right, but it is his left. And then there is a zoo. From the zoo, he drove 2 kilometers on the right side and he reached his home. Okay. So this was the guy Deepak's path. This path was Deepak's path. And what is this guy Sanjay doing over here? Sanjay drove to his school, drove 1 kilometer. So the description of Sanjay's thing is given over here, which is this particular path. We understood that much. That's enough. Let's go directly to the questions now. First, what are the coordinates of the hospital? So let's locate the hospital here. We see the hospital is there over here, right? We have the hospital marked here. What are the coordinates of this hospital? 3. Let me zoom in over here. This is 3, 2. X coordinate is 3, Y coordinate is 2. That's all. The second thing. In which quadrant or quadrants did Deepak drive? So the passage was important here for us to understand who was Deepak, who was Sanjay. We know Deepak was driving in which quadrants. He drove first along the x-axis. Then he reached over here the third quadrant. This quadrant over here is third quadrant. Then from there, he moved towards the fourth quadrant. So you can just write third, fourth quadrants. That's enough. And for the last part of the question, write the coordinates of the midpoint of the line segment connecting hospital and zoo. So I need hospital's coordinates and I need zoo's coordinates and I need to find the midpoint of that. Where is the hospital? The hospital is over here. Coordinates are 3, 2. And the zoo is here. The coordinates are 3, minus 2. Yeah. 3, 2, 3, minus 2. Actually, this was quite easy to find without midpoint formula. You could have just from the graph seen the midpoint of this line segment joining hospital and zoo is what? 3, 0. Correct? That is easy. 3, 0 you could have got directly. If you are using midpoint formula, what would you do? You will add the x coordinates. So 3 plus 3, you will get 6. 6 divided by 2. And you add the y coordinates. 2 plus minus 2, 0. 0 divided by 2. Yeah, that would have been the coordinates of the midpoint, which is same 3, 0 only. So sometimes in case studies, it's good when you have the graph marked correctly. You can use the graph only to help you answer. Next one is find the distance between the temple and the zoo. Okay. We already know that this is the odd question. Okay. We already know that the zoo is 3 comma minus 2. What were the coordinates of the temple? The temple's coordinates was minus 3 comma minus 2. Okay, here also we do not need distance formula. From the graph, we could have got the answer. If you use distance formula, answer would be root of 3 minus minus 3. Difference between x coordinates is 6. Root of 6 square plus minus 2 minus minus 2. What is minus 2 minus minus 2? Minus 2 plus 2, which is 0. So I would get the answer as root of 6 square. Root of 6 square or root of 36 is 6 only. But in this particular case, you could have just added this, right? We could have added 1, 2, 3, 4, 5, 6 and got directly the distance between temple and zoo as 6 units. So whenever you have a graph which is properly given, please try to make use of that, use it to your advantage and get the answer by using that graph paper itself. All right. So I hope this discussion was useful for you. We have covered some important concepts in this particular video. And I think many of these questions are sure shot questions which would appear for your exam if you have these chapters appearing for the exam. And please do share in the comments if there are any doubts. I will clear that. If you have any tips on what changes you would like to see, how I could improve the video, you can mention that also. Please subscribe so that you're updated about whatever videos I'm uploading with regards to 9th grade papers. Thank you. Bye-bye.